in case it wasn't clear, the subatomic particle in a quantum that engages in it, that does a quantum leap, all of a sudden goes from one orbit to another orbit, or to another orbit, or back to the previous one. But if you imagine that the distance between the orbits is enormous, which comparatively it is, the either or is created by the fact that it skips the distance. It's kind of like if I'm in Chicago and I'm going to Mexico City, but you never catch me on the fucking road between Chicago and Mexico City. It's almost like the universe is saying, when we get down really small, I'm gonna show you that I'm either gonna put myself here or I'm gonna put myself there. What about in between? No in between. What the universe is telling us when we observe the subatomic particles with the quantum leap is an either or situation where there are two very distinguished orbits separated by a humongous distance. But even though the subatomic particles are here in one of the orbits, and then they're no longer here, but they're there, they never, ever are anywhere in between the two faraway orbits. They're either, as they move, you're either going to find them in one spot, or you're going to find them in another spot, or you're going to find them in another spot, or you're going to find them in another spot. But in the distances between these two distinguishable spots, you're never going to find them. So you're either going to find them in a spot, or you're going to find them in another spot. Either there or there, but never in between. Never in between. The two spaces, the two orbits or three orbits or whatever, or 10 orbits are separated by huge distances. But the universe is telling us we distinguished this one from that one. We're going to put there's a huge distance between this one and that one, but we're either going to be in this one or we're going to be in that one. And when we go from one to the other, it's not like moving on a ruler from 1 inch to 10 inch to 12 inches. We're either going to be on the 1 inch mark or the 8 inch mark or the 12 inch mark. Fine. It's like taking a ruler and saying we're going to have a 12 inch ruler and we're going to have a notch on the 1, on the 2, on the 3, on the 4, and so on and so forth to the 12. And we're going to move anywhere on this ruler, we're either going to be on the 7 or we're going to be on the 3, and then we're going to go to the 8, and then we're going to go to the 5. But this ruler has no notches in between. That's why it's called quantum physics, because it's quantic. Quantic meaning that it's a quantity that is no longer that is essentially is like, instead of being a ruler with 12 inches, it's 12 notches. And so you can count them quantitatively. There's one notch, there's another notch, there's another notch. So you can count them. Quantic, quantity, 1, 2, 3. But it's not a ruler, because you can only be on the 1 notch or the 5 notch or the 9 notch. You can be on all of them, not at the same time, either here or there. Either on the 6 or did I mention them all? The 8, the 9, the 10, the 11, the 1, the 2, the 3, the 4, the 5, the 6, the 7. But while the scientist is looking at the ruler, the universe is only looking at the notches. It's only saying, I'm either going to go here or I'm going to go there.